All right, so we're gonna do a lot of different problems. So we'll start out with evaluating functions. We'll go on to some true and false and other mathematical concepts. So let's go with the first one. We have f of x equals 9x plus 3 factorial minus a half, 0.5. And we want to evaluate f of 0 first. So let's try that. We just plug in wherever we see an x, we just plug in 0. So 9 times 0 plus 3 factorial is 3 times 2 times 1, which it will become 6 minus 0.5. So 9 times 0 becomes 0. 6 minus a half, it's going to be plus 5.5, which is exactly what f of 0 equals. So f of 0 is going to be 5.5. Let's evaluate, I don't know, f of 2, for instance. That would be 9 times 2 plus, it's the same 3 factorial, there's no variable attached to it, so we leave it. So that's 6 minus 0.5, which is 5.5 as we had before. But now we just have 18 plus 5.5, which will be 23.5. If you do 18 plus 5, which is 23, and attack on a half, which will be 23 and a half. And that is what f of 2 is. All right, so that's one. Let's do more problems. Let's solve an equation like this. 4x plus 2 equals 10. We want to know what x is. So we can start out by subtracting the 2 from both sides in order to preserve the equality, because both things on the left and right are equal. So you're left with 4x equals 10 minus 2, which is 8. And you could do the inverse operation of multiplication, which is division. Then you get this is what x is equal to, 8 divided by 4, which is also 2. So that is what x is. Let's go on to some true and false equations. Let's see, is 23 greater than 23? No, that is false, because they are equal to each other. They're not greater, they're not strictly greater than itself. Yeah, 43 minus 10 is greater than 29. That 43 minus 10 is 33, which in fact is greater than 29, so that is true. Let's go on to pi is equal to 3.14159. That is in fact not true, just because pi is irrational number. It goes on forever, so this is just like an estimate, an approximation, but it goes on for infinity. So that's why it cannot be equal to this specific set of numbers. There's infinite more numbers after, in fact. So that is why this is false. Let's see, e is less than pi. So pi is around 2. Well, we know pi is like 3.1459 onwards and onwards. The value of e, which is another number, is around 2. Let me get a little bit better value, but it's around 2.718, I believe, 28, and so on and onwards. But in fact, we just need the beginning parts. So this is in fact true because it's 2.7 or something, as opposed to 3.4 and onwards. I mean, it's important to know these are both irrational numbers, so these things go on for infinity, but we can at least know from the beginning parts that this has to be true. And then tau, which is like this, is that equal to 2 pi? And it is, that's by definition. And again, then if pi is irrational, that means this is also irrational, which is tau. So that's also irrational, but since we are just doing 2 of this, and by definition, this is true. So that's a lot of this. Let's do some, equations and solving stuff. So if we have x minus 2, x minus 3, we want to find out what the value of this expression is. Remember, this is an expression, and this is an equation with an equal sign. This is an equation. this is an expression because there's no equal sign anywhere. All right, so let's do, we want to find out the value of this when x equals 0, let's suppose. So we just do q minus 2. And right there, I honestly know the answer is going to be 0 just because this is 0 and 0 times any number, it's 0. But yeah, if you also want to do it, it would be 2 minus 3, which is -1. But which 0 times -1 is also 0. So this whole expression turns into 0. Let's do this. 2 plus 3 minus 5. So in this case, PEMDAS, which is the order of operations we want to operate in. So you do, since there's no parentheses, no exponents, no multiplication or division, we're into the last two, which is addition and subtraction, left to right. So let's do 3 plus 2, which is 5. 5 minus 5 is 0. So the whole expression becomes 0. Yep. So let's do another one. 2 plus 4 times 5. In this case, we have multiplication, which we will do first then. So it'll be 2 plus 5 times 4 is 20. And 2 plus 20 is 22, which is your answer for that one. Let's do -3 times -1, which is also, expressible by just writing like this, just down next to each other, which is explicit. It's like an expression for multiplication, and this just becomes +3. Negative times a negative is positive, and 3 times 1 is 3. That is one way of doing it, and if that's what that is equal to, let's get a little bit more creative with the parentheses so we can test PEMDAS really. I'm gonna do this and evaluate this expression. So again, you do parentheses first. So the first thing is 2 plus 1, which is 3. 3 minus 1, which is 2. And all this is in the big parentheses, which means you should focus on this first. And now it's just multiplication inside. 3 times 2 is 6, plus 2. So you do get 8 as your answer for that one. Let's do a little bit more. Let's do 3 times 30 plus 10 in the numerator of fraction, and you're going to divide that by 2. And just remember, all these can have point zeros, which is fine, or zeros in front. The leading zeros don't really do anything in this case. So let's do PEMDAS again, which again stands for parentheses, exponents, multiplication, division, addition, and subtraction in that order, with the multiplication and division and addition and subtraction being left to right, with multiplication and division taking priority. So in this case, let's do the so this can also be written as this plus 10, this whole thing divided by 2 in that sense, because the 2 goes to everything in that sense. So let's just do whatever is inside the parentheses first, essentially. So we have a multiplication and addition, so we can do the multiplication first. So 3 times 30 is 90, and you add 10. And then this is still in parentheses, so you still want to stick with that. So that means 90 plus 10 is 100. And then you could do this 100 divided by 2, which is 50, which will be your answer. All right, let's do a little bit more. 3x plus 9 is going to be equal 0. So solve for x. We could do just subtract the 9 to get a simpler equation. And then you could just divide it by the inverse operation, which is 3. Be careful of the negative sign, it stays there. So in this case, x is going to be -9 divided by 3, which is -3. And you can always check it by doing the other way around. So -3 times 3 should give you -9, which it does. So you know you're right, and you can move on to this problem, which looks intimidating, but it really is not. You have this, and which is equal to x plus y plus z minus b, and all these are variables, plus 2. Okay, that is a minus sign right here. So So it reads x plus y plus z plus b, all variables, equals x plus y plus z minus b plus 2. And you want to solve for the values of x, y, z, and b, because they're all variables. Let's see what we could do. So initially, it does look like, it's almost impossible, because in order to solve 4 variables, 4 unknowns, you need 4 equations, and we just have 1. But the good thing is, in this case, since it's an equal sign, we know the left and right has to be equal. So if you do something to the left side, we have to do the right side. And a lot of these variables, they're doing the exact same thing. So if you could just subtract x from both sides, and that will maintain this equality, because you're doing the same thing to the left, same to the right. It, in essence, stays the same, the true value. So you can get rid of this and get, so x's are gone, which means they're basically 0, because you can just add 0 to both sides, and the equation will still be true. You can do the same thing for y, same thing for z, and that just literally just reduce your problem down to 1 variable and 1 equation, which is exactly what we look for in these situations. The same number of equations as the same number of unknowns. So now we're left with b. It's going to equal to, let me cross this z's out. B is going to be negative b plus 2, and then you can just add b to both sides. This cancels out, so you get 2b is equal to 2 divided by 2. And you're left with 2 over 2, which is 1, which is the answer to this problem. All right, let's keep moving on. So you have 3x plus 5y is going to equal 15. And you have 2x minus 5y equals 25. And you want to solve for what is x, what is y. So in these systems of equations, there's 2 unknowns and 2 variables, which is nice. So we know we can at least solve this. In this case, there's 2 methods of usually solving these equations. One is the substitution method, which you don't have to worry about. In this case, there's an easier method, which is elimination. So you're trying to basically get rid of a variable by either adding and subtracting these 2 equations. In this case, I see a plus 5 and a minus 5. So if you add them, you get 0y, which basically gets rid of y and simplifies your system's equations to 1 variable and 1 equation. So you can solve for x and then plug it back in to find y. So let's add them up. And this is like regular adding. I usually put parentheses because you're subtracting. Everything has to be distributed. But in this case, you can go about doing this fine. So 3x plus 2x is 5x. And that does not look like a 5, but that's a 5. 5y minus 5y is 0. So that you eliminate these essentially, which is the point of elimination. And then you do 15 plus 25, which brings you to 40. And then you can do divided by 5 divided by 5. So x is going to be 40 divided by 5, which is 8. 5 times 8 is 40. That checks out. So we now know 8 is x. So now we can just again, if you want to solve for y, we can do a very similar thing. But now we know x is 8. So we can just plug that in. So 3 times 8 plus 5y is going to be 15. So let's plug back. Let's evaluate this a little bit more. So 8 times 3 is 24. So 24 plus 5y is going to be 15. Subtract the 24, subtract the 24, and that will give you a value on the right side of -9. So you have 5y. It's going to equal -9, and then you can divide by 5, So -9/5 is y. And let's check, because it's always good to check. But I have our y and x and y values, but it's definitely worth to check it, because you can in these just plug it right back in, and you'll know if it's right or not if you try it out. 3x plus 5y equals 15 is one equation. So remember, our answers were x equals 8, y equals -9/5. Let's see. So let's try it. 8 times 3 is 24. If you plug in 8, wherever you see an x, and y, you can plug in negative 9/5. So 8 times 3 is 24. 5 times negative 9/5 is 9. The 5's can cancel out, so just 9. And 24 minus 9, the last time I checked, it was 15. So that one checks out. Let's try the other one, because they should both work because they're systems equations. Let's see. So you have 2x minus 5y. It's going to be 25. If you plug in 8 here and negative 9/5 here, let's see what we get. You should get 25. 8 times 2 is 16. And the 5's, they're going to cancel out. So you're going to look at plus 9 because it's a negative 5 times a negative 9. Like a negative times a negative, which becomes positive. So 16 plus 9. The last time I checked was also 25, which means we are good. Everything checks out, so we know those are the right answers, and we can move on to other problems that are really fun. So let's do z. That's a variable z, where 4 equals 12. In this case, you could just multiply both of the sides by 4, because that will cancel out, and you're just left with that just implies z is going to be 12 times 4, which is 48. All right, let's do this. X divided by 4 plus x divided by 4 is going to be 1/4. So in this case, there's one trick. If every single term in these equations is being divided by 4, you can essentially get rid of them because you're doing the same thing to every single term, and the left side of the whole equation is equal to the right side of the equation. So that is allowed as long as they're the same. In this case, it is allowed. So you pretty much just left with x plus x equals 1, which is 2x equals 1, which is x equals half. If you don't want to do that, that's fine. Let's try to do another way, like more mathematical way, if you really want. X plus 4 plus x divided by 4 equals 1/4. So let's combine here. You get common denominators, so you could just do 2x over 4 is equal to 1/4. I'll just multiply both sides by 4. That's allowed. You can also just multiply this whole thing by 4, which is actually what we're doing technically. So yeah, this by 4, this by 4, this cancels out. So you're also left with 2x equals 1, meaning x is half. And yeah, that's that equation. Let's do 64 equals 6y plus 8 plus 2y. Okay, first thing, there's these things that have both y's and numbers, constants and variables, same variable, which is key. So you can combine like terms. You get 64 equals 6 plus 2 is 8. So you get 8y plus 8. And then you could just do your simple math again. 64 minus 8 would become 56. It's going to equal to 8y divided by 8 on both sides. So then y is going to equal 56 over 8, which is also known as 7. And that is your answer. Let's move on to this one. 5x minus 3 divided by 2 is going to equal 11. Again, just multiply this whole thing by 2. And you also got to do it to the right side. If you do it to the left, this will cancel out. You're left with 5x minus 3 equals 11 times 2, which is 22. All right, now it's one of those simple equations again. We could do plus 3 plus 3. So you're left with 5x equals 22 plus 3 is 25. So divide by 5. Oops. So you're left with 5x equals 25. And divide by 5 on both sides. And then you're left with 25 over 5, which is also known as 5. So that works out there. All right, let's do some absolute value problems. In this case, there's actually going to be 2 equations just because, -1, the absolute value, that does not look like an absolute value. That's a -1. Oh, absolute value of -1 is 1. But the absolute value of 1 is also 1. So there's like 2 answers. So you basically set this, whatever's inside here actually, to the both positive and negative versions of that, and you solve. Why, you asked? Well, let me write this down again. So if this equals 6, that means this whole thing can be, it could be this, because that equals 6, or it could be this, right? Because these both absolute value equal 6. So you just literally negate, you can actually just negate this side. It would probably be better. Let's try it. Let's see what works. So if you negate that one, let's see. We can always check it. And if it's right, it'll be right. You'll know it's right because you can check it. Which is always a good strategy in this problem. So 10 minus 2x, that's supposed to equal 6. Negative 10, if you distribute, this is like a negative 1 in front, so negative 10 plus 2x is equal to 6 plus 10. So you get 2x is going to equal 16 divided by 2 divided by 2. I got x equals 16 divided by 2, which is 8. Let me plug in really quick to see if this works. And that might not be the only answer, but we'll try it. Let's see if 8 is an answer. So you have 10 minus 2x equals 6. So 10 minus 2 times 8 is going to be 10 minus 16, which is going to somehow equal 6, does it? 10 minus 16 is negative 6, which the absolute value of negative 6 is 6. So yeah, that does work out. And then you could, so x equals 8 is an answer. Let's try the other version because, again, there's 2 answers for these just because of the reasoning before. So you could just set the positive version of that equal to 6 because, you know, positive 6, absolute value of 6 is 6. So now you have negative 10 minus 10 is equal to, so you get negative 2x equals, that is a 6 minus a 10, which is a negative 4. So negative 2, you have x is negative 4 over negative 2, which negative divided by negative is positive, 4 divided by 2 is 2, so it should be 2. Let's see if that works in our answer. So you have 10 minus 2 times 2 equals 6. That is the absolute value sign. 10 minus 4, which is 6, and the absolute value of 6 is 6. So yep, our answers then are 8 and 2. And you move on. All right, suppose x is 10, and x plus delta x, that's a symbol is a change, is 15. How would you solve for delta x? Well, in this case, we technically have 2 equations, and like we could just plug the x in here. We know what x is, so let's just do that. 10 plus delta x is 15, and that just basically is a simple equation now. So this is just a number, so we can just do this. So just subtract 10. We have delta x, which is a change in x, is 15 minus 10, which is 5. That's all. You could just do that as a simple way. All right, this one, they're called officially, or mathematically, I guess they're called literal equations, I believe, which just means they're basically equations without numbers. These are all variables. And if you recognize that, that is the linear, like equation for a line, but you don't have to worry too much about that. So let's see what it's asking. Y equals mx plus b. It's asking you to solve, let's solve for x. So, but these are all variables, but that's fine. You can still do that. That's not a problem. It's just that your answers will have variables instead of numbers. So how would you regularly do this? You subtract the b, because the b's are going to cancel out. But on the left, instead of like, you know, a number, you just get y minus b, which will be a number if these are numbers as well, or if that's how the equation set up, then yeah. So you left is y minus b on the left, and just mx on the right. How to get rid of the m? Since they're multiplied, you just divide by m. And that is how you solve for x. And these are just in terms of variables. There is, nothing you really have to do. These are just variables, and you can leave it like that because you don't know any numbers. If you get told to plug in numbers, you plug in right in, and you have your answer. Those are fun. All right, this is a interesting problem. I think it doesn't look like it, but 6 divided by 2 times 1 plus 2. All right, again, pandas. That will always come into play in these situations. Okay, let's do the parentheses. So 6 divided by 2 times 3. So what do you do now? Remember, it's multiplication and division from left to right. And from left, you actually have to do the division first. Even though it seems like these will be first because they're right next to each other, that's just implying these are just multiplication. So it's like this. This is much better with right. So you just do this first. So 6 divided by 2 is 3. And then you multiply by 3 to get 9 as your answer. And that is how pandas would work in that situation. Okay, this one is a very just like a problem solving method. What number plus 2 by itself is going to equal like the same number, just the absolute value of it. So this requires, you can do it as like easy way. I thought initially as like a number line of 0 is at -1, 1, -2, 2. So the thing is, if you do -2 and you add, like 3, you get 1. You just get to the other side if you add a certain number. So I thought of it should be probably a negative or small negative, because it has to satisfy this equation. So I tried -1 and it ended up working. Trial and error, I guess. And let's see why it works. So you have -1 plus 2. That gives you a positive number, which is 1. But that is also equal to the absolute value, which is positive, which is good, of -1, because we said y is -1, and 1 is the absolute. -1, the absolute value of -1 is 1, so this checks out. So you get, for y, you get -1 as your answer. A little bit trial and error, but that's how some equations are. All right. Okay, this is a little bit tricky one. Which of these is the most wrong equation? Fraction, if that makes sense. There's a fundamental, like a question, I guess this is trying to ask, which I will go through one by one. All right, actually, let's change that -2 to -1. 1 doesn't really make a difference. So fractions. Oh wait, there's also this one. Yeah, so it's 1, 2, 3, 4, 5. Okay, so fractions, they represent rational numbers. Like all rational numbers can be expressed as a fraction theoretically. Yeah. So these like half is a fraction. Half is a fraction. 4 is a fraction. We've seen it everywhere. This, it can be written as a fraction, so 1, as long as it's terminating and, normal. And it's not too wrong, I guess you could say. Again, same thing here. Even if there's a 2 there, it's still, it's like ends. Like it terminates, essentially, is the idea. So that's why this is a weird one. Pi or 1. Pi itself is like literally infinite. Like there's just number. It never stops. So this whole thing cannot really, it's not like a positive, like it's not a terminating number essentially, because it's pi. Pi or 1 is pi, and pi can't write pi as a fraction. Just 3.14 just goes on forever. It's not like never stops. So that's why this is the most wrong. If that makes any sense. All right, a couple more fractional stuff and exponent stuff, and we'll be over and done and learned a lot. Okay, let's do multiplying fractions. So that's 5/8 times 3/4. Multiplying fractions is pretty easy. You just do the top and bottom by itself. So that 5 times 3 is 15. 8 times 4 is 32. And that's your answer. And you move on. Let's divide, which is easier. not easier, I meant it's a little bit more challenging, but you actually turn it into multiplication just because multiplication is that easy. So you could do keep. This is the general rule. Keep, change, flip. That is not how you spell flip. Maybe that's how you spell. It's flip. So let's do an example. Yeah, 5/8 divided by 3/4. All right. So you keep the first fraction, which is 5/8. You change this division sign into a multiplication sign. And when you flip this last fraction, like literally flip it, so it's 4/3. And then you just do multiplication as normal. So it's 5 times 4 is 20, 8 times 3 is 24. And that's your answer. You can simplify this, but you don't have to, but that is your answer. All right, that's how you do division. Let's do adding and subtracting fractions. They're very similar, but there's just one idea of the common denominator. So what you need in order to add or subtract the fractions. All right, so let's do that. 5/8 plus 3/4. You can't really add them right now because the denominators are different. You're adding different like portions of a pizza, and it's not the same like standard. So that's where you want to get common denominators. So I think the easiest way here is just if you multiply this, the top and bottom by 2/2, this whole thing is 1, and any number by itself it's that number. So you're preserving the equality, but you could do that because you're doing the top and the bottom. You're basically multiplying by 1 because 2/2 is 1. So that becomes 5/8 plus 3 times 2 is 6, and 4 times 2 is 8. And now you have common denominators, and now it's simple as pi. 6 plus 5 is 11 over 8, and you're done. If it's subtracting, you could just do 5/8 minus 6/8. If this was a minus, then it will be 5 minus 6 is -1, 8. And that's how you do adding and subtracting fractions. So the key idea is the common denominators one. All right, let's go into our last topic for today, which is about exponents, which are basically repeated multiplication. Repeated multiplication. So what do I mean by that? Let's do 2 to the 5th. That is literally just 2 times 2 times 2 times 2 times 2, 5 times. Why 5? Because that's what this 5 is telling us to do. So this is just math at this point. So you have 2 times 2, which is 4. And then 2 times 2 is 4. And then you just have an extra 2. That's how we break it down. So now you have 4 times 4 is what? 16. And then you just have times 2, which is then 32. So that whole thing is equal to 32. And that's basically the idea of exponents. There's some cooler, rules that would be helpful, but before we get to that, we could just, do another couple of problems. These are rules / just facts. So what's 1 to 0 tower? That is equal to 1, and that's a rule. Any number, anything essentially, to any number, naturally also can be variable because like x0, x to the 0, you don't know what x is, but you do know the answer. Oops, you do know the answer. Why? Because anything to the 0 power is 1. Any number to the 0 is 1, and any letter like variable to the 0 is also 1. So like x to the 0, you don't know what x is, but you know this is 1. Yeah. So that raises the question, because 0 is always that interesting, of 0. What's 0 to 0? It turns out it's 1 as well, not some weird number with like mathematical special things of 0, like 0 factorial is 1, and stuff like that. So now we can get into the exponent rules. which are a couple of them. There's like, let's go on to the, like, let's start with the basics ones, like addition. It has to do like operations. So if you're doing, let's call it variable a, b, let's call it b, whatever. So b to the a times b to the, so that's confusing. D, a, b, c, d, b to the e. Sure, that is actually, that e is not the number e. That's like a variable. Just call it x. It's fine. This, when you're multiplying two exponents to the same base, you just add the exponent. So that is just equal to a plus x. All right. If you're doing like division, ba over b to the x, that is just subtracting the exponents. Yep. If you're doing power to the power, so like a to the x to the b, that's just going to be a to the xb. You multiply when it's power to power. You can do also negative exponents, which are basically like this. So a to the negative b is going to be 1 over a to the b. So you just do 1 over, and the same thing, just you make the exponent positives. Yeah. So yeah, and anything to the a to the 1 is a, 1 to the 1 is a. Any number to the first power is itself. That's the rule. And anything, again, to 0, it's 1. Okay, let's do like a couple of problems. Actually, let's do one problem that's kind of involves a lot of rules. So if this is what they gave us, 3x minus y equals 12. That's what they gave us. And they told you to find the value of 8 to the x and 2 to the y. And they gave you like 4 choices or a couple of choices, I guess. Actually, they don't want to give you choices. Whatever. Just find the value of this. Right now it seems impossible because it's like literally like x and y's and stuff like that. And they want like a number or at least some like expression that you can evaluate or put in the calculator and get a number. But when you look at this, you notice 8, 2, and it looks like there's a minus y, there's a 3 coming in from somewhere. So after some digging around, you realize that 2 cubed is 8, right? And 3, you have 3 in there, you have an 8. So this looks promising for some reason, but then you're gonna have to use exponent rules. So yeah, this looks promising. So you can actually just plug this in here instead of an 8. So you get 2 cubed to the x power, because this 8 is like, the whole thing is raised to that. You get this all over 2 to the y. And now we're cooking, because now you could, do the exponent rule of power to the power, you multiply. So you get 2 to the 3x over 2 to the y. And now it looks really, like they gave you this 3x minus y, and you have a 3x and a y. And you also have division, which you can use that rule to get 2 to the 3x minus y. Because when you're dividing with the same base, which is why we did this whole thing, because we wanted these to have 2 bases. These rules work when you have same bases. Now this is simple, because 3x minus y is 12. So this just becomes 2 to 12, and this is a number, which it's big, but we don't have to worry about that. You can plug this in the calculator or just do the math for real long. But that is in fact the answer. And yeah, that is the answer, and that is our end of this session of fun math problems. And we'll be back. Thank you very much.